All right, so we have in the rectangular coordinate system, we've already talked about an ordered pair or a coordinate. So this one has an x coordinate, which is first, and it has a y coordinate, which you see second. So we could say that this is a coordinate pair. Or we can say it's an ordered pair. So if I give you a list in a table of xy coordinates, I could have a 1, a -3, a 2, a 5, and an 8. A 1, a -3, a 2, and a 5, and an 8. I just confused myself. All right, a -4, a 6, a -3, a 4, and a -8. This is just another way to write ordered pairs. So an ordered pair from this table would be a 1, -4. It would be a -3, 6. It would be a 2, -3, a 5, 4, and an 8, -8. And I'm going to take this a step further, just kind of sort of fine tune it. And I want to know which quadrant each one lies in. So I would start at 0. Remember, the first one tells you left, right. It's left if it's negative, right if it's positive. The second one tells you up, down. So I would go right 1. So from the origin, I would go right 1, down 4. So that tells me I'm in quadrant 4. Okay. This one, I would go left 3, up 6. So I would be in quadrant 2. In this one, I would go right 2, down 3. So I would be in quadrant 4 again. On this one, I would go right 5, up 4. So that tells me I'm in quadrant 1. And on this one, I would go right 8, down 8. So that would tell me I am in quadrant 4. All right, so now that we've kind of sort of gotten the hang of how to do this, and by the way, some people will do this to these, and it just makes it a little bit easier to see which quadrant you're in, but technically that's not right. Anyway, all right, so I now want to give you, I have y equals 2x minus 4. Okay, so let's talk about this for a second. This is a linear equation. How do I know it's linear? Because I've got x's and y's, and my biggest exponent on each is a 1. He's got a 1, and he's got a 1. Okay? So this, we call it a first degree. This is first degree because it's a 1. This is first degree because it's a 1. So this is linear. It has x's and y's, which means it's diagonal. Okay? So I want to potentially find, remember this is like the little recipe that we use to find the line. So what I have is, what happens if I ask you to substitute in a 4? What would happen? And so what it's going to return is a single point on that line. Now, which coordinate is this? This is your x coordinate, which means I know an x value. So I have y equals, wherever there's an x, I'm going to put a 4. And then I'm going to finish out the math. So that gives me y equals 8 minus 4, which means y must equal 4 as well. So if I evaluate it 4, it returns a 4, which means you just figured out that out of an infinite number of points on the line, this one is on there. The 0.44 is on this line. Okay? Let's try another one. So what happens if I have something like 5y equals 4x minus 20? Okay, this one was in slope-intercept form. So it said y equals mx plus b. So my slope was 2, and my y-intercept was -4. Because you could say plus -4. Okay, so this is in y equals mx plus b. This is in slope-intercept form. This one's not. Okay, this one is in a mess. So I can divide everything by 5. And then he'll be in y equals mx plus b. He will be in slope-intercept form. But what I may want to do is go ahead and subtract 4 from both sides. And now, here's what I want you to notice. 20 is my constant. But 5 goes into 20 and 4 goes into 20. So that's kind of a neat little trick right here. So what I'm going to do is called graphing using intercepts. Okay, so what I will do is I'm going to zero out my x, and I'm going to zero out my y. And we're going to do a lot of math in our heads. So in this one, I'm going to kill off my x. So this is what I have. So I've got 5 times some number is negative 20. Well, what's the number? That number, if I divide both sides by 5, will give me a negative 4. Okay, so let's plot that and see what we've got. So that's at 0, negative 4, so he's down here. You just found the y-intercept. You just found the place where this thing crosses the y-axis. Okay, so now let's zero out the y. So if we kill y, that means I can add 20 to both sides. So I'll get 20 equals 4x. And then I can divide both sides by 4, and I get 5 equals x. So now I have another point on the graph, and that would be move right 5 and stay still. So I've got 2 points, make a line, but now I've got an infinite number of points on it. Now that was a little bit difficult to do in our heads. So what we could have done, which I started to say, and I corrected myself, is I could subtract 4x from both sides. And now my new equation, which is a little bit easier to work with, I should have got a new piece of paper, is a negative 4x plus 5y is a negative 20. So this is now in standard form almost, which I'm going to leave that alone. Okay, this is almost in standard form. We usually don't like to lead off negative, but I don't care right now. So what happens if I zero out my x? Kill off the x. What do you got? Well, then y must be negative 4. Okay, and this just makes it a little bit more organized. So what happens if we kill off our y? Then x must be positive 5. Okay, because negative 4 divided into both sides would give me a 5. So if we organize it appropriately, then we can find these intercepts. So this is called graphing using intercepts. Okay, so let's try another one. We're going to graph this equation by plotting points. So I've got a y plus an x is a negative 3. And you should notice something at this point. First of all, I got x's and y's, and their degrees are 1s. This makes a diagonal line. So this is a linear equation. It makes a diagonal line. I also notice it's almost in standard form, but my x's and my y's are flip-flop, and that bothers me. So I'm going to put them in alphabetical order. And now I can plot using intercepts. So this is a 1 and this is a 1, which means every coefficient divides into negative 3. It's harder to do with fractions. Okay, that's why we kind of sort of make it a point to say on this one, well, 5 and 4 both go into 20. So that we can do in our heads. Okay, on this one, 1 and 1 both go into negative 3. So we can do this in our heads. So I am going to plot 2 points with zeros. Okay. And so I know that x is going to go to 0. So if I kill off my x, what do I get for y? I get a negative 3. Okay. Now return back to the other equation. And now I'm going to kill off my y. So wherever there's a y, wherever there's a y, I'm going to put a 0. So kill him off. And now x must be negative 3. So there's negative 3. So if I plot this, the first point, which is going to be my y-intercept, is at 0, negative 3. So that's my y-intercept. This one is called my x-intercept because it's where it hits the x-axis. So I'm going to go negative 3, 0, 2 points, determine a line, and there's my line. So there's an infinite number of points on the line. I only need 2 to find it. Okay? So let's try something that's not so easy. I've got a y equals 1/2 x minus 6. Okay, so you should recognize this as y equals mx plus b. So y equals mx plus b. Okay, so this is where I'm going to try a couple of different things. The first thing I'm going to try is this thing is screaming at me. I've already got a single point. I already know that the y-intercept is -6. Okay, so if I shove in a 0 for x, that means this term goes away. What's your y-intercept? It's -6. So I already have a point. Now the next fun thing that I can do is I can find the next point by using this slope. And this is, my slope is rise over run. So I'm going to go up or down, depending on if it's positive or negative. And then I'm going to go right. Okay, and as soon as you've established a second point, you can start finding other ones. But here's what I'm going to do. I have 0, -6, so here's 0, -6. And now this slope tells me to go up 1, right 2. So I'm going to go up 1, right 2. Okay, which means, what point is that? It'd be easier if I had graph paper. Hey, look, I do. Okay, so I'm at 0, -6. And then I could go up 1, right 2, which means this point is now, good heavens, that's hard to see. Hang on, give me a second while I amuse myself drawing lines. All right, these are the axes, and it's really difficult to see on this paper. Okay, so I'm in quadrant 4. I went up 1, right 2, which means I'm at the point 2, -5. Okay, so I'm at the point 2, -5. So that's another point on the graph. So this one gives you a different approach to graphing the line. The other one I used 2 intercepts. This one I use the y-intercept, and then this is the recipe for how to get to the next one. Okay, so from here, from your intercept, you're going to go up 1, right 2. Up 1, right 2. So there's my other line. Now, I can do that mess like this, and then 2 points determine a line. Okay, so I have an infinite number of places. Now, just for kicks, I could have subtracted my 1 over 2x. So now I've got a -1/2 x plus y is -6. Okay, and I could have multiplied through by -2. Now I'm not advocating that you do this. I'm just saying you could have. Okay, so -2 times this gives me an x. -2 times this gives me a -2y. -2 times -6 gives me 12. So what would have happened with my intercepts? I could have had 0 out my x, and y would have given me, divide both sides by -2, -6. That's exactly what I got up here. Okay, 0 out my y, and x would have to be 12. So when I look at this cool little line that I just randomly slashed through, hang on, I have a Home Depot coupon. Okay, I've got a 1 and there's a 2, a 1, 2. I'm getting there. He's like that. There we go. All right, if I had drawn that line this way, now you can see I've got an x-intercept at -6, and I would have a y-intercept. It's off the graph, but here's 10, 11, 12. Okay, so I've got the same line both ways. It just depends on if we want to be a lazy math person or not. Okay, so if I'm plotting points, and hopefully at this point you've got it, any point on the x-axis will have a y-coordinate of 0. If it's going to land on the x-axis, the y-coordinate will be 0 because I don't move up or down to get off the axis. Any point that lies on the y-axis will have an x-coordinate of 0 because I didn't move left or right to get off of it. Okay? So now let's look at this one a little bit closer. If I have y equals -7 plus 8, y equals -7x plus 8. So what form am I in? What form am I in? I am in y equals m, which is my slope, x plus b. So this is supposed to be a fraction. I can write anything over 1. So what's your y-intercept? Well, if I shove in a 0 for x, my y-intercept is 8. So this thing hits the y-axis at 8. To get my next point, I would drop down 7 and write 1. Down 7, write 1. Okay, so let's try another one. This was in slope-intercept form, so the y-intercept is just screaming in your face. Okay, Let's do another one. I've got a 2x plus 8y is 16. So first of all, what form is this in? I've got x's, then y's, then equals a number. So this is in standard form. And the next thing I notice is that 2 and 8 both go into 16. So this makes life really easy if I want to graph using intercepts. So if I want to kill off my x, what does y have to be? I would divide both sides by 8 and get a 2. If I want to kill off my y, what would x have to be? X would have to be 8. Okay, so this is my y-intercept because I didn't move left or right, but I did go up 2. This is my x-intercept because I moved right 8 and did not go up down. Okay, so let's look at a few more. We have, okay, I've already done ones. In fact, we might be done. Okay, I think that's good. All right, so you are ready to finish this section. And that means you're ready to go on to the next section when you're done with this one. So let me know if you have questions.